Okay, so today we're talking in 12.1. We're going to talk about sampling and good sampling techniques. We're going to talk about frequency distributions, which is one way of displaying data. We want to talk about graphs, specifically about deceptive graphs and some of the things you want to avoid in your displays of data. As always, we have some objectives. And so our first objective is to describe a population whose properties are to be analyzed. And this is really important. Then we're going to select an appropriate sampling technique. Once we've identified the individuals that we're looking for and what property, we need to know how to take a sample of that population so that we can analyze that property. Then we're going to organize and present the data. In this video, we're going to do that using a frequency table, okay, and talk about a histogram and a polygon chart. And then we're going to identify deceptions and visual displays of data so that you can recognize those in other people's work and avoid them in your own. Now, this is probably one of my favorite slides of this semester because people ask me all the time, what is statistics? And so statistics is a distinct branch of mathematics where we use a method of collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on that data. The methodology for this is divided into two main areas: descriptive statistics, which is what we're going to focus on in this chapter, which means collecting, organizing, summarizing, and presenting the data. And then inferential statistics is when we make generalizations about and drawing conclusions from the data collected. And this is more of what you would do in your stat methods class if you choose to take that after this class, which I highly recommend. All right. And so now one of our objectives was to talk about populations and sampling. And so what is a population? A population is a set. All right, everything goes back to sets and the set theory that we did in the original chapter. Containing all the people or objects whose properties are to be described and analyzed by the data collector. All right, so what we're talking about is we want all of the objects, okay, who has a property that we are looking at. So all of the objects with a particular property. So a sample is a subset or subgroup of the population. So the sample is taken out of the population. And then this is huge. A representative sample, a sample that exhibits characteristics typical of those possessed by the target population. If we do not have a representative sample, okay, if we do not have a representative sample, then, right, here's our if-then statement from the logic. If we do not have a representative sample, then we cannot say anything meaningful about the population. Okay? Basically, the old adage is if you have junk data in, you're going to get junk conclusions out. And so, if you do not have a representative sample, then we can't say anything meaningful about the population. And so this is really important to keep in mind. So what we're going to do now is we're going to talk about how do we identify the population, and then how do we try and get a representative sample. Alright, so a group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. Describe the population. Well, the population here are the citizens of the large city, right? So the citizens of the city, okay? That's the actual population. Their opinions about gambling may be a property, okay? So this right here, their opinions on gambling are going to be a property that we analyze, but who in the set has that property? The citizens of the large city. Okay? And that's really an important point. So, it is suggested, right, to survey all of the people at 6 of the largest nightclubs in the city on a Saturday night about their opinions on casino gambling. Is this a good idea? Okay, well, let's think about this, right? The idea behind a good sample allows, all right, all members of the set of the population, we should use the proper word here, of the population, a chance to be selected. Okay? So a good sample, a representative sample, is going to allow all members of the population a chance to be selected. Okay? So now let's look at what is being suggested. It is being suggested that people, right, at nightclubs on a Saturday night are the ones that are interviewed, right? So people at nightclubs on a Saturday night. Does this fit with our idea of a good sample where all members of the population can be selected? And hopefully you come up with the answer of no. All right? So we have people that don't go to nightclubs. Therefore, right, the 3 dots mean therefore, we do not give everyone a chance. Okay? And so maybe people who attend nightclubs are more predisposed toward the property that you're looking at. Maybe people that go to nightclubs are less predisposed to what you're looking to analyze. And so you get a biased sample. And so no, we have to give everybody a chance to be selected. So this is a terrible sampling method. Alright? So how can we make it a good sampling method, right? Well, we want a random sample. Alright? A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected. So the methodology that you use for a random sample, simplified obviously, is identify each element of the population. Who are we looking at? Assign numbers to each element of the population. You know, give it some sort of a number, okay? Randomly select, do something so that everybody has the same chance, and then put those people from that set and analyze their opinions, okay? Ask them the questions. So one of the things that we might do here, if we're trying to identify each element of the population, maybe we're looking at the population of Valencia students, right? And then assign numbers. Well, the numbers that you could use would be the VID. This strips away all of the gender information, ethnic information, socioeconomic information. The VID is just a number. And so if you're looking at all Valencia students, the VID is a great way to collect an unbiased sample. And then randomly select numbers. Use Excel or some other program to randomly select VIDs, alright, and then assign elements of the population whose numbers are selected, right? And so then you just contact those students whose VIDs have been chosen. And that's your smaller sample. And the reason we would want to do this is because there are about 60,000 Valencia students active in any given school year. And so we can't ask all 60,000 of them a question about parking or the cafe or textbook costs. But what we could do is use their VIDs to randomly select a small group, maybe about 1,000 of them, and contact these students through email and interviews, right? And that would give us a way to understand what it is that we want to learn about. Okay? 60,000 is just huge. Okay. Now, how do we select an appropriate sampling technique, right? So which is the following is the best way to select a random sample to find out how the city citizens feel about casino gambling? So what if we randomly survey people who live in oceanfront condominiums in the city? Is this a good way to randomly select a representative population? Right? I hope you're screaming no at my video right now. All right? Because not everyone lives oceanfront. Right? So therefore, not all members of the population have an equal chance. And so if you're only asking oceanfront people, maybe they're biased against casino gambling because they don't want the noise and the tourism and the traffic and stuff. Or maybe people who live on the oceanfront really like the idea on the whole of casino gambling and the extra revenue that it would bring in and maybe boost their businesses and stuff. There's no telling. But the oceanfront is not going to have the same proportion of people in support of the casino as probably the city as a whole, all right, because this is a biased sample, and these particular individuals have all chosen oceanfront, which means there's a certain amount of similarity in their thinking, and so that's going to heavily weight whether they are or are not opposed to the casino gambling. So it fails that not all members of the population have an equal chance, and so we don't want to use it. All right. Now, what about if we change this up a little bit and we survey the first 200 people whose names appear in the city's telephone directory? Now, let's think about this, right? It does seem fairly random, first 200 people whose names appear. We're just selecting a bunch of people, we're thinking, but the answer here is actually no, okay? This is not a random sample because, again, not everyone has a chance, right? Nobody with the last name of Z is going to have a chance. Nobody with the last name of W probably is going to have a chance. And so while it may be hard to see how people whose names end in A and B have a similarity, what we don't know is what the ethnic makeup is of the city. You know, maybe there are a whole bunch of Adams that live in the city, and so because of the large family there, maybe they have some quality together. All right? We just don't know. And so, but because not everyone has a chance, we feel like this sample could be biased in a way that is not representative of the population as a whole. And so you want to avoid this technique. This is lazy. The first 200 people, it's just lazy. All right? So now, what about randomly select neighborhoods and then randomly survey people within the selected neighborhoods? Now this gets the big yes. This is what we call a stratified random sample, because what we're doing is we're looking at the large of all neighborhoods, and so each neighborhood had a chance, all neighborhoods, each neighborhood had a chance, check, okay, and so because each neighborhood had a chance, all citizens had a chance, okay, check. And so, therefore, this meets the criteria. So I randomly select neighborhoods, and as long as I select enough neighborhoods, then I'm going to get a representative sample of the city. And then as long as I select enough citizens inside there, then you know you've got a good sample. Now, how much is enough, we're going to talk more about in stat methods and in other videos, but for right now it's just enough to know that this is a good way of sampling. Alright, so now your sample is concluded and now you collect some data, right? So now let's look at our frequency distribution. Okay, so what we were interested in was a boy's age of maximum yearly growth. So this is the big growth spurt where they gain the most height and weight from one year to another. I know for myself, when I was in high school, there was a summer that I grew like 1.5 inches and gained 10 pounds. My son did the same thing. Okay, so there is a year when you have more growth than others. So we go through and we say, all right, our smallest number is 10. The boy hit the growth spurt really early. And then we have the biggest number is 18. And so this was a boy who hit his growth spurt fairly late in life, right? We're looking at more adolescence. And so, but we have all of these 35 years of maximum growth. And so what I want to do is see if there's some sort of a pattern by going through and marking the frequency at which the 10, the 11, and the 12, and so on and so forth show up. So basically, I'm just going to scroll through and look for a 10, and then I cross it out and put it over here, right? And then I'm scrolling through, and I'm looking for a 10, and there isn't one. Now I'm going to look for an 11, okay? And once I find the 11, and there's one there and one there, I'm going to put those two frequencies there, right? Now I'm looking for a 12. So there's one 12 there on that row, none on this row, a 12 on this row, 12 on this row, 12 on this row, and a 12 on this row. So we got 5 boys that did 12. All right, now we're looking at 13. So there's a 13. 2 13s here, 13 here, 13 and 13, 2 more 13s, and another 13. So it looks like certainly 13 is in the running right now. 3 14s, 4 14s, 5 6 14s, 7 14s, and then 2 more. Right, there we go. So we have 9. So 14's looking pretty good. Alright, now what about 15? Alright, so 1, 2, 3 15s, 4, 5 15s, 6 15s. So it looks like 14 is the most because now it seems to be going down. 16 once, 16 twice, 16 3 times. Now as you can see, there's not a whole lot left, right? So there's 117, 118, and that's it. And so I have crossed everything out. It didn't look like I missed anything, and I can tell that with the crossing out. And so here's my table. And so now what can I say about this table, right? The maximum amount of growth occurred mostly for 14-year-olds, but it seems to be centered around 12 to 15-year-olds. Okay? And so we have this wonderful slide right here. What are some of the conclusions that we can draw? What are some of the inferences? Maximum growth for most subjects occurred between ages 12 and 15. And then the number of boys who attain their maximum yearly growth at a given age increases until age 14 and then decreases after that. And of course you can certainly see those two observations. 14 is the max, we ramp up to it and we get fewer after it. And except for the 16 which has 3 in it and the 11 which has 2 in it, pretty much all of the growth happens between 12 and 15, right? Over 5, over 5, right? So all of these are where most of the growth takes place in that late adolescent stage. All right? So now, what if our data is spread further apart, right? What if we have test scores for 40 students, and so instead of having a narrow range, what if we're going from, let's see, 47 is a pretty low score. I don't think there's one. 43, 45, those are pretty low. So you're from 40 to 93, 2, 3, 4, 94s. And so you're going from 43 to 94, right? So basically that's a 51 point spread. Okay, 51 points. Now I don't want to have 51 individual values here, and especially because some of them aren't even going to be represented. Okay, not every 40 score is going to be represented, not every 90 score is going to be represented. So what we do is we're going to group these frequencies into classes. Okay, into classes. In statistics classes, we might call this also the bin width. It's how wide are we going to make this so that it's meaningful. And I think this is the really important idea to understand, is it does have to be meaningful. Okay? So since letter grades are based on 10-point ranges, what would have the most meaning would be 90 to 99, which is an A, 80 to 89 B, 70 to 79 is a C, 60 to 69 is a D. And now you have your, just barely below D, barely failing, more failing, okay? And so this gives us 10-point ranges. You do not want to clump these together, okay? Do not make one bin. You always want to keep your bins the same size. Otherwise, you start to get into misleading statistics. And so just be real careful about that. I know that F's go from 50 to 49, but it starts making the failures look exaggerated. When you break it apart like this, it's a lot easier to see where the center is. Okay? Now, we can organize this, and I'm not going to go through that tedious process again. We already did that with the boys' scores. But you would go through and you would go, all right, is the score between 40 and 49? If it is, it gets marked. Between 50 and 59, and it gets marked, right? And so you can see that we're building to the maximum, and then we're getting smaller again for a total of 40 scores. Okay? And so you're like, oh, so the class width is 10. It is sometimes helpful to vary the width. So I disagree with this, okay? I think that this is very bad. I know that Blitzer says it is sometimes helpful to vary the width of the first or the last class to allow for items that fall above or below most of the data, but you have to be super careful about this, because what he's talking about is outliers, okay? And the tendency is to say 40 to 50 is an F, and so let's put those together. But then what happens is you get a score of 9 here, and then it goes down, and then it goes up, and then it goes down again, and it looks like a very different type of distribution. And so you have to be very careful about this. I would recommend don't do this, okay? It's just too easy to get in trouble. Don't do this. Alright, so we have this particular picture, alright? And now what we want to talk about is a histogram or a frequency polygon, right? So these are two different ways that we can display data. Sorry about that. All right, these are two different ways that we can display data. A histogram is a bar graph with the bars that touch because the data is continuous. It can be used to visually display the data. Okay? Excuse me. And so these are the data. A frequency polygon is a line graph formed by connecting the dots in the midpoint of each of the bars of the histogram. So what I'd actually like to do is do this frequency polygon with the boys' ages of maximum growth, right? So we did that frequency table. And so what I'm going to do is I'm going to show you how to put that frequency table into your handy dandy calculator. Alright, so usually the first thing that I do is I'm going to push the second button and then the plus sign, which is memory, and then I'm going to clear all lists is number 4. Alright, so I'm going to clear all lists and then I hit enter. And what that does is that clears all of the data that I might have had in the calculator before and allows me to start fresh. And so now we're in the stats chapter, and so the stat button is the second down from the middle, and so I'm going to use that stat button right there to edit a list, and so I'm just going to hit enter. Okay, now for some reason it starts off in the middle, so I'm going to use the D-pad right here to scroll over to the left, and now I'm just going to put each one of these scores in. 10, enter, 11, enter, 12, enter, 13, enter, 14, enter, 15, enter, 16, enter, 17, enter, 18, enter. Okay? And now I'm just going to put in the 1, 2, 5, 7, 9, 6, 3, 1, and 1. And now it's very important that these bottom lines line up. Okay, and so now once I have the data in, I want to make sure that my plot is on. So I'm going to go to my stat plot, because remember we're using stat data, and it's blue, so I hit the blue button and the stat plot, and I'm going to hit enter again to make sure that my stat plot is on. Now it defaults to a scatter plot, so what you want to do is use your D-pad to scroll down, so just hit the down arrow, and over to the histogram bar graph, and hit enter. And now what it's going to ask for is I scroll down. List 1 is where all the values are, and the frequency is where L2 is. And so I'm going to hit second 2. Second 2 gives you L2 in there. Now once you have your plot on and it's set to be a histogram and you have your list and your frequency table in there, then you're going to hit zoom and then number 9. Zoom 9, and you get this frequency table in here. Now sometimes the calculator, when you hit the zoom button, will make it a little bit weird. So what you want to do is you want to hit window, and the scale is 1.33. In the book they're using a scale of 1. The class width is 1. That's the one thing that the calculator is terrible at. It doesn't always pick the correct scale here. So I'm going to change that to a 1, hit enter again, and now I look at my graph, and this is what my graph should look like. Okay, so there's my histogram. Now if I wanted to make it a frequency polygon, I just go to second stat plot again, hit enter, and you'll notice the second one over, enter, is connected dots, and so now when I go to the graph, there's my frequency polygon, right? And so those look like the two that I just looked at, right? With my bar chart and my frequency polygon. Alright, that's going to do it for now. We're going to do visual displays of data in the next video. Thank you for watching.